The sky was calm, deceptively calm. The kind of silence that sits heavy in the air, moments before nature decides to reveal its wildest mood. Then, somewhere in the distance, a low, rolling thunder begins. The clouds twist and churn, forming a dark, swirling mass. The air turns heavy, the pressure drops, and in an instant, the horizon gives birth to one of nature's most violent creations, a tornado. Tornadoes have fascinated, terrified, and humbled humankind for centuries. They are the purest display of atmospheric imbalance, where warm, moist air collides with cold, dry air, and the atmosphere begins to spiral into chaos. Within seconds, what began as a simple storm cell becomes a rotating monster capable of wiping entire towns off the map. But among the countless twisters that have torn through history, a few stand apart. These are the strongest ever recorded, storms so powerful that they defied measurement, reshaped landscapes, and changed our understanding of weather forever. Before diving into the most powerful of all, it's worth understanding what a tornado really is. At its core, a tornado is a violently rotating column of air that extends from a thunderstorm to the ground. You often can't see it until it picks up debris, dirt, and dust, forming that haunting funnel shape that defines it. The conditions for a tornado are precise and rare. You need warm, moist air at the surface, cold, dry air aloft, and just the right kind of wind shear, where wind speed and direction change dramatically with height. When that shear is stretched vertically by rising air, the atmosphere begins to spin, and if it spins fast enough, the storm can evolve into a supercell, the birthplace of the most violent tornadoes known to man. Scientists measure tornadoes using the Enhanced Fujita Scale, or EF scale, ranging from EF0 to EF5. An EF0 might peel off a few roof shingles. An EF5 can turn a neighborhood into splinters and leave nothing but foundations. But some storms have gone beyond even that scale, with winds so fast that instruments couldn't even register them. One of those storms occurred on May 3, 1999. It began like any other spring day in Oklahoma, humid, unsettled, and restless. But by late afternoon, meteorologists were watching something extraordinary form over the small town of Amber. On radar, a supercell was strengthening rapidly. The conditions were textbook perfect for violent tornado formation. And then, at exactly 6:54 p.m., the storm touched down near Bridge Creek. What happened next became meteorological history. The tornado rapidly intensified as it moved northeast toward the city of Moore, growing in size, speed, and fury. Mobile Doppler radar picked up something scientists had never seen before: wind speeds exceeding 500 kilometers per hour or over 318 miles per hour. That made it, officially, the fastest wind ever recorded on planet Earth. Homes were not just destroyed, they were erased. Cars were hurled hundreds of meters through the air. Pavement was peeled off the roads. In just under an hour, the Bridge Creek Moore tornado left a trail of devastation stretching over 60 kilometers long. Entire neighborhoods were flattened. 36 people were killed. More than 8,000 homes were obliterated. The damage reached over $1 billion, a staggering amount at the time. And yet, from that unimaginable destruction came a breakthrough in our understanding of storms. The data gathered from the 1999 tornado helped scientists improve early warning systems and refine Doppler radar technology, saving untold lives in the years that followed. But just over a decade later, nature would once again test humanity's limits. On May 31, 2013, near the small Oklahoma town of El Reno, another storm began to form. At first, it appeared to be a typical severe thunderstorm. Nothing extraordinary, but within minutes, it exploded into something massive, chaotic, and unpredictable. The El Reno tornado began as a narrow funnel, but quickly ballooned into an unimaginable width. Within half an hour, it had grown to 4.2 kilometers across, over 2.5 miles wide, the largest tornado ever observed in recorded history. What made the El Reno tornado particularly deadly was its erratic movement. Unlike most tornadoes that follow a clear path, this one shifted direction without warning. Its rotation was complex and multi-vortex, with smaller funnels orbiting the main one like planets around a sun. Even experienced storm chasers who had spent decades studying tornadoes were caught off guard. Among those tragically killed were the respected scientist Tim Samaras, his son Paul, and meteorologist Carl Jung, pioneers who had dedicated their lives to understanding these storms. Although the El Reno tornado reached wind speeds of nearly 480 kilometers per hour, it was not classified as an EF5. Ironically, this was because it passed mostly through open fields, leaving limited structures to measure damage against. Yet in the scientific community, it remains one of the most powerful and dangerous tornadoes ever recorded, a monstrous reminder that width and unpredictability can be just as deadly as speed. While modern instruments captured the El Reno and Bridge Creek tornadoes in detail, the deadliest and most haunting tornado of all occurred nearly a century earlier, long before radar, satellites, or warning sirens existed. On March 18, 1925, the tri-state tornado ripped through the American Midwest, leaving behind a path of destruction unlike anything before or since. It began near Ellington, Missouri, and grew quickly into a mile-wide wedge of swirling death. Over the next 3.5 hours, it carved a continuous path of 352 kilometers, that's 219 miles, making it the longest-lasting and farthest-traveling tornado in history. The storm roared across Missouri, Illinois, and Indiana, flattening towns as it went. In Murfreesboro, Illinois, the tornado hit during the school day. Entire school buildings collapsed. Families were torn apart. In total, 234 people died in that town alone. By the time the skies cleared, the tri-state tornado had killed nearly 700 people and injured more than 2,000. 15,000 homes were destroyed. It moved faster than any tornado on record, with estimated forward speeds approaching 100 kilometers per hour. Survivors described it as a black wall moving across the land, swallowing everything in its path. Without modern technology or early warning systems, people had no idea what was coming. Many mistook the dark funnel for a dust storm until it was too late. Even today, meteorologists still debate whether it was a single continuous tornado or a series of overlapping funnels. But one thing is certain: the tri-state tornado stands as the deadliest in American history, and perhaps the most terrifying display of atmospheric power ever witnessed. So what makes these tornadoes, Bridge Creek, El Reno, tri-state, so powerful? The answer lies in the science of instability. Tornadoes are born when the atmosphere becomes unbalanced. Warm, moist air from the Gulf of Mexico rises and collides with cold, dry air from the Rockies. When the winds above the ground blow in a different direction than those below, the air begins to roll. Add a powerful updraft, and that rolling air is twisted vertically, forming a spinning column. If the energy is strong enough, the vortex touches down, and the tornado is born. Inside these violent funnels, air pressure drops lower than anywhere else on Earth's surface. The pressure difference between the inside of a tornado and the surrounding air creates suction powerful enough to lift entire houses, strip bark off trees, and hurl debris miles away. Scientists have recorded pieces of mail and household items found hundreds of kilometers from where they originated, carried through the sky by these unimaginable forces. Thanks to technology, we can now detect the earliest signs of rotation before a tornado even forms. Mobile Doppler radars, drones, and weather satellites allow scientists to measure the anatomy of storms in real time. Every major tornado we experience today helps improve forecasting models and public warning systems, increasing survival rates year after year. Yet even with all this technology, one truth remains: we can never fully predict when or where the next monster will appear. Behind every statistic is a human story. Families huddled in basements, Meteorologists staying at their posts to issue final warnings, storm chasers risking their lives to gather data that might save others in the future. Each disaster is a lesson written in the language of wind and chaos, and each survivor carries a story of resilience. The strongest tornadoes in recorded history remind us not just of nature's destructive power, but of humanity's capacity to adapt, learn, and endure. From the Bridge Creek Moor tornado's record-breaking winds, to El Reno's unimaginable size, to the Tri-State Tornado's unmatched death toll, each of these storms tells a part of a larger truth. They are a mirror reflecting both the fury of the natural world and the courage of those who face it. In the end, tornadoes are more than just storms. They are symbols of balance and imbalance, destruction and rebirth. They remind us that in a world governed by forces far greater than ourselves, humility and knowledge are our greatest defenses. We cannot stop the wind, but we can learn from it. And in learning, we honor those who have faced its wrath and survived to tell the tale. Because knowledge, unlike a storm, endures forever.